Welcome to The Explainer. Today, we're unpacking a highly specific yet absolutely critical piece of the sustainability puzzle, mastering the SASB distribution network efficiency metrics for water utilities. Honestly, if you want to understand the true operational health of a water system, this is exactly where you need to look.
To really grasp why these metrics matter, I want you to picture a water utility as this giant, sprawling circulatory system. It's pumping life-saving, thoroughly treated water across vast distances, day in and day out. But what happens if that system is compromised? Imagine losing massive amounts of that precious resource straight into the ground before it ever even reaches a customer's tap. Where does that missing water actually go? And probably more importantly, how do we even begin to measure the impact of losing it?
The stakes here are incredibly high. Globally, we're talking about billions of gallons of treated water simply vanishing into the ground every single year. When we talk about non-revenue water, we're talking about this massive invisible drain caused by leaky, aging infrastructure. But it's not just the water itself that gets squandered, we're also completely throwing away all the costly resources required to process it. That means the energy consumed for withdrawal, conveyance, and treatment, plus those really expensive treatment chemicals, all of it, just completely wasted.
Okay, let's dive right into this. Here is our blueprint for today. 1. The hidden infrastructure problem. 2. The efficiency blueprint. 3. Calculating main replacement rates. 4. Defining non-revenue water. 5. Measuring real water losses. And finally, 6. The value of efficiency.
Starting off with Section 1, the hidden infrastructure problem.
Look, we all know water utilities don't just lay a simple pipe from point A to point B. They develop, maintain, and operate incredibly complex, interconnected infrastructure networks. We're talking extensive pipelines, canals, storage reservoirs, and massive high-capacity pump stations. And because these systems are so vast, and let's face it, often aging rapidly, they are highly prone to failures. Those infrastructure failures don't just waste water, they directly hit a utility's financial performance and inevitably force customer rates to go up.
Which brings us to Section 2, the efficiency blueprint. Looking directly at the Sustainability Accounting Standards Board, or SASB framework, you can see exactly how the industry standardizes this issue. Under the distribution network efficiency topic, there are two specific quantitative metrics we need to look at. Today, we're going to focus laser-tight on calculating these two. IFWU 40A.1, which is the water main replacement rate, and IFWU 40A.2, the volume of non-revenue real water losses.
Let's tackle that first one in Section 3, calculating main replacement rates.
Now, before we do the math, we absolutely have to define the scope. What actually counts here? According to the standard, utilities have to include complete water main replacements, as well as any major rehabilitations or renewals that substantially extend the life of the main. This applies to potable water distribution and even non-potable uses like fire suppression. But here is the critical distinction you have to remember. Standard water main repairs are explicitly excluded. You literally cannot count a simple patch job as a replacement. Also, just a quick reminder, wastewater and stormwater pipes, they are completely excluded from this specific metric.
So let's look at the actual calculation blueprint. To find the replacement rate, you really just need two basic numbers. First, measure the total length of pipe that was replaced or fully rehabilitated during your reporting period. Second, determine the total length of all water mains currently in your distribution system. Then, you just divide the replaced length by the total length. Let's say you replace 10 miles of pipe in a 1,000-mile network. Divide the replaced length by the total length, and there's your rate. Simple as that. That resulting number gives stakeholders a very clear, standardized view of exactly how rapidly a utility is actively upgrading its physical network.
But, numbers in a vacuum aren't really enough, right? Which is exactly why SASB requires utilities to provide reporting context. Utilities have to discuss their maintenance strategies, specifically the balance between planned maintenance, which happens before a failure, and corrective maintenance, which is essentially putting out fires after an asset fails, sometimes literally. They also need to explain the unique challenges their network faces, like the age of the current infrastructure, how soil properties or corrosion are attacking the pipes, and their actual ability to finance these replacements through rate adjustments.
Moving right along to Section 4, defining non-revenue water.
So the crucial point here is understanding exactly where the utility's responsibility ends. Non-revenue real water losses are strictly the physical losses of water that occur before it can be billed to a customer. Geographically speaking, this means tracking water from the pressurized system and storage tanks and stopping right at the point of customer consumption.
For metered customers, that boundary is the customer's meter. In unmetered systems, it's the exact point where the customer takes over responsibility for the service connection piping.
So what are the actual physical culprits of these real losses? We're talking about literal water escaping the system. This includes leakage from the main pipelines, bursts at those service connections we just talked about, or even instances where storage tanks physically overflow. And just to reiterate a really vital rule for this SASB standard, any losses related to wastewater or stormwater services are strictly excluded from this calculation. We are only tracking distributed water here.
All right, Section 5, Measuring Real Water Losses.
When you're reporting the volume of those non-revenue real water losses to align with the SASB framework, you must quantify the total volume using one highly specific unit of measurement, 1,000 cubic meters. Consistency in this specific unit is exactly what allows analysts to compare performance fairly across different utilities all over the world.
Of course, actually measuring water that has disappeared into the ground is, well, it's pretty tricky. So SASB provides a clear reporting hierarchy. Your first stop is the primary method. You calculate losses according to applicable jurisdictional laws or regulations. If your local area doesn't have those, you default to the secondary method, which is calculating the volume according to accepted voluntary initiatives. Finally, utilities always have the option to disclose the specific, highly technical measurement techniques they employ to track down and quantify that lost water.
Let's wrap this up with Section 6, the value of efficiency. Ultimately, this whole process isn't just some dry accounting exercise. It is the absolute bottom line of efficiency. By rigorously tracking that replacement rate and quantifying the water loss volume in cubic meters, a utility can effectively limit those non-revenue losses. Less lost water means less wasted energy and chemicals, which drastically reduces operating costs. Simultaneously, it increases the volume of water that actually makes it to the billing meter, boosting revenue. When it comes down to it, this data is a literal roadmap that guides strategic capital expenditures. It tells a utility exactly where to efficiently direct its funds for pipeline refurbishment, improving the overall value of the entity and providing really strong investment returns.
Which brings us to the ultimate question you should take away from this explainer. Are your utilities leaks silently draining your revenue? Or are you going to use these efficiency metrics as the catalyst to drive your next great capital investment? I want to thank you all so much for joining me today. Keep asking the tough questions, keep examining the data, and I'll catch you in the next explainer.